student of class 12th, once again we are here with a new video, and in this video we are going to discuss about the dual nature of radiation and matter. In the previous video we had discussed about Einstein equation, properties of photon and laws of photoelectric emission. About so many terms we had discussed in the previous video. If you had not watched that video, first go to all those videos and make your concept clear, then you come on this video. In this video we are going to discuss what is the dual nature of radiation and matter. So wave theory of electromagnetic radiation explained the phenomena of interference, diffraction and polarization we had already discussed in the previous chapters. On the other hand, quantum theory of electromagnetic radiation successfully explained the photoelectric effect, Compton effect, black body radiation and X-ray, etc., etc. So the radiation have dual nature, that is wave and particle nature. Louis de Broglie suggested that the particles like electron, proton, neutron, etc. also have dual nature. That is, they also can have particle as well as wave nature. So in no experiment matter exists both as particle and as a wave simultaneously. It is either that one or the other aspect, that is the two aspects are complementary to each other. The suggestion of de Broglie's were based on the nature of symmetry, and the universe is made of particle and radiation, and both entities must be symmetrical. According to de Broglie, a moving material particle can be associated with a wave. That is, wave can guide the motion of the particle. Means de Broglie said that if a particle is moving, if the material particle is moving, so it is like a wave. It is producing a wave. So the wave is associated with the moving material particle are known as de Broglie wave, or we can say matter wave. So what the explanation of de Broglie is, according to quantum theory, the energy of photon is E is equal to h nu and it is equal to hc by lambda. So according to Einstein theory, the energy of photon is E is equal to mc square. So lambda is equal to h upon mc, or we can say lambda is equal to h upon p, where p is equal to mc, where c is the velocity of light and p is the linear momentum. So momentum of photon is p is equal to mc because photon is moving with the speed of light. So we are taking c here in the place of v. So but it is a similar thing. So p is a linear momentum and p is equal to mv we had learned, but here we are using c because photon is moving with the speed of light and the symbol for speed of light is c. If instead of photon we have material particle of mass m moving with velocity v, then the equation will become lambda is equal to h upon mv. Suppose that the particle which has mass m moving with certain velocity v, which is less than velocity of light, so we can change the relation h upon mv, means lambda is equal to h upon mv. So this is the expression for the de Broglie wavelength. So what is the conclusion? Conclusion is de Broglie wavelength is inversely proportional to the velocity of particle. If the particle is moved faster, then the wavelength will be smaller and vice versa. If the particle is moving very fast, the wavelength will be smaller, as you see the relation, and it will be vice versa. Means if it is moved faster, then wavelength will be smaller, and if it moves slower, so the wavelength will be larger. If the particle is at rest, the de Broglie wavelength is infinite. Such a wave cannot be visualized. The third is de Broglie wavelength is inversely proportional to mass of the particle. The wavelength associated with the heavier particle is smaller than that of the lighter particle. Means the de Broglie wavelength, what the wavelength suggested by de Broglie, is inversely proportional to the mass of the particle. Smaller the mass, bigger the wavelength. The fourth is de Broglie wavelength is independent of charge of the particle. Matter waves like electromagnetic waves can travel in vacuum and hence they are not a mechanical wave. Means matter wave need medium to propagate. Electromagnetic wave which are independent of medium, they can travel in vacuum, and matter waves are not electromagnetic wave because they are not produced by accelerated charged particle. And matter waves are probability, matter waves are probability waves, amplitude of which give the probability of the existence of the particle at that point. These are the conclusions made by de Broglie, and the properties of equation given by de Broglie wavelength. These all are the point. These are very important. You see from your NCRT also, and with your reference book also, and watch this video. And if you have any problem, then you can call on my number.
Photoelectric effect and wave theory of light. Wave theory fails to explain the characteristics of photoelectric effect. According to the wave theory, energy and intensity of light wave depend on its amplitude. Hence, energy of photoelectrons should increase with the intensity of light. But experimental results indicate that the energy of photoelectrons does not depend upon the intensity of light. According to the wave theory, energy of light has no relation with its frequency. Hence, change in energy of photoelectrons with the change in frequency cannot be explained. Photoelectrons are emitted spontaneously. This cannot be explained by wave theory. Free electrons in a metal is emitted only when it gets certain minimum energy called work function of the metal. If the light has wave nature, free electron in metal may get energy gradually, and some time elapses before it gets energy equal to its work function and gets emitted. This is the contradiction to the spontaneous emission. With less intense light, the emission of electrons will be slower as per the wave theory. But with light of sufficiently high frequency, emission of photoelectrons is immediate even if its intensity is low. Einstein's photoelectric equation, energy of quantum, radiation. In 1905, Einstein explained photoelectric effect using Max Planck's quantum theory. Planck had assumed that the emission of radiant energy occurs as photons, but after emission it transmits as a wave. Einstein assumed that emission, transmission, and absorption of light takes place in the form of photons. According to Einstein, when light in the form of photon is incident on a metal, it is totally absorbed, and its energy is partly utilized to free the electron from the metal surface, work function phi naught, and the remaining energy will be imparted as kinetic energy to the ejected electron. Thus, energy of photon equals to work function plus Ke maximum. E equals to phi naught plus Ke maximum. H nu equals to H nu naught plus Ke maximum. Ke maximum equals to H nu minus H nu naught. According to this equation, maximum Ke depends linearly on nu and is independent of intensity of radiation. Since Ke maximum cannot negate H nu greater than H nu naught or H nu greater than nu naught, writing the equation in terms of stopping potential, EV naught equals to H nu minus H nu naught. V naught equals to H by E minus phi naught by E. The graph of V naught versus nu is a straight line with slope equal to H by per electron and intercept on x-axis, nu naught. Thus, experimental plot of the graph of V naught versus nu could be satisfactorily explained by Einstein, for which Einstein got a Nobel Prize. The intensity of light incident on the metal surface is the amount of light energy incident per second per unit area normal to the surface. According to the photon theory of light, intensity of light I equals to nh nu, where n equals to number of photons incident per second per unit area and h nu equals to energy of photon of light of frequency nu. Thus, according to the photon theory, more the intensity of light, more is the number of photons incident per second. Hence, more photoelectrons are emitted and the current increases with intensity. Thus, photoelectric effect could be satisfactorily explained with the photon theory.